We have been given a problem between Nancy and Shelly trying to decide what a vector is. So Nancy proposed that we're gonna have this one as x hat being in the same direction as our vector, because you have something that you want to push it down a hill, and that's the vector is going to be vector A, which has a magnitude of 2.5 meters per second square. God, my English. And then y hat like that. But Shelly says, let's use the normal one. Let's use x and y hat. So I first decided to do what Shelly is trying to make, and then you go to Nancy. Shelly says, okay, we have the A vector going down, so we're gonna use our algebra thing, and you find that, okay, if you have a one line and then we have two parallel lines, the angle from here and angle over here has to be the same. So there's gonna be a 50 degrees angle. So you have vector A, vector, then x hat. Remember, it's a unit vector, so it's going to have a 1. Or if you even have a vector, it's going to be still 1. You're going to propose. So 1 times 2.5, that we have meters per second square, times cosine of 15, because we have 15, which we get 2.41 meters per second. Remember, the units going to be stay the same. So we get the answer of the dot product very easily. Although we're gonna do one algebra thing. Let's see if Nancy's approach is gonna be easier or not. Let's go ahead and do that. Now let's try to do this Nancy's one. Nancy's one is not gonna be that much difficult, because when you do that, x, whatever vector we're gonna put on it, and the x hat, is gonna be the same direction that we had for a vector. So we have the a, vector a, and x hat. Put each other as the vectors, and we get the cosine between them is gonna be 0. We're not going to play the 15 anymore, because we don't have angle between them 15. Remember last time we had to find that angle, because we had to use very formula stuff, but this one, because they go in the same direction, they're not going to have any angles between them. So you got 2.5 meters per second times 1 times cosine of 0, you get 2.5 meters per second. We get the same thing as our vector, because the cosine of 0 is 1. So as you can see, it's less step to do with Nancy, but it's still recommend doing Shelly's work, because we get the standards, and you have the y, x, y hat, and z hat. We also have a z hat over here as well. But the thing with Shelly's is, then Shelly, we're gonna get the different dot product, and we're gonna actually understand physics a little bit more. That's why I do Shelly's better than this one, because seems to be very similar to what we have as our vector thing, which dot product is supposed not to be similar. I don't know if this is true or not. Dr. Lin can prove me wrong or not. But I think that's going to be like the case. And for the components, we know, well, for that one, we know that if you have a magnitude of x, and if it goes only for the x part, we don't have any z hat and y hat. It's just 0. It's a 0 z hat, 0 y hat, and we're going to have like 1 x hat. Same thing with the last one. And then 2.5 is going to on the x direction, or even if it's going like down to x, we have like negative y, because we have 2.5. So that means 1 on the x hat, means like 2.5 on the x hat, and then negative 1 on the y hat to get that component. And then we pretty much got everything that we need to cover. We get all the scalars. We know the scalars and vectors are different. Remember, the x hat is having its own symbol, and a is a vector, and vector is not a very like a scalar. And a scalar is gonna have meter per second square, which then gonna make us have these statistic stuff to do. With zeros, it's supposed to be positive, I think, because it's acute a little. It's not really in an angle, but the other angle that we have is also positive, because we had an acute angle. So that's acute dot product, and then yeah, that's pretty much it. Hopefully you guys learned something. That's the vectors. Hopefully this question give you a little better understanding of what we do. I still recommend Shelly, but you can go over and recommend Nancy. Hopefully you guys learned something new, and see you guys next.